Hello again. We are now discussing Chapter 3, Section 5, talking about the standard form of a line. And you're probably starting to wonder, what is the deal with all these different forms? How is standard form different than anything else? Well, standard form uses ax plus by equal to c, where a, b, and c are all real numbers and all non-zero. A and b are non-zero. C could be zero. A and B, or AX and BY, would actually have to be additive inverses at that point, but we will get to seeing when that would happen. Now, why do we use standard form of a linear equation? What does it do that my other forms can't do? Well, the first thing that's the easiest to do with it is find your x and your y intercepts. Now, how we could do this? Now, if you think about a coordinate grid, x and y, and you think about the intercepts, like say I intersect here and intersect here, well, at this point my y-intercept, what do I know about x at my y-intercept? Well, x has to be 0 and y has to be some value. Same thing at my x-intercept, except here I have an x value of something and a y that is 0. So in order to find your x and your y-intercepts, all we want to do is substitute in x for 0 and solve it, then substitute in y for 0 and solve it. So take a moment, try this on your own. I will be back in just a second to show you how it works, but go ahead and pause if you think you can and go for it. So when I plug in 0 for my x in my first equation here, my 5 times 0 obviously gives me 0. So then my negative stays with my 6. So I have negative 6y is equal to 60. Because this is multiplied, I know that I should divide. And when I divide by a negative, well, I have a positive divided by a negative, so that means it's going to become negative. And that gives me a y value, a y-intercept more so, of negative 10. So that tells me where my line would cross my y-axis. Now what about where it would cross my x-axis? Go ahead, turn this around and plug in 0 for the y. So then I get to a point here, because my negative 6 times 0 is 0. I now have 5x equal to 60. So again, because these are multiplied, I can just divide. So I divide by 5 on both sides, and I see that x here would then equal 12. So this is not one point. These are two different points. I have now found a point that is the y-intercept, making x 0 and y negative 10, if my negative will stop disappearing. And then I've found another point where my x is 12 and my y is 0. So now I've actually got 2 points for the graph, and I could really quickly put both of those points down, connect them with a ruler or something, draw my line, and there you have your graph. If you have not done it yet, try B on your own. So when I solve out for equation B, I plug in x as 0, solve that out, get 8y equals 12, do the division, simplify, and find my point of 0, 3/2. And then when I substitute in y equal to 0, solve that equation separately, I get that x is positive 4, so I get the point 4, 0. Again, I could put those 2 points on my graph, connect them, and then I would have my line. Especially if you cheated on those last 2 and did not pause the video. Now you need to pause the video and solve this, finding the x and y intercepts. Find them both as points. Don't just give me an x and a y. You need to give me 2 points. One is the x-intercept, one is the y-intercept. Pause it, solve it, do it now. So if I set this up, again, you can choose which you substitute in first, but I'm going to go ahead and substitute my x in first. Really, you can essentially then forget about the x term. So then we have 3y is equal to negative 7.5, so on both sides we could divide by 3. We would then get that our y value is equal to negative 2.5, which then makes this point my y-intercept, since x was 0, to my y-intercept. So my y-intercept point is 0, negative 2.5. So then to find the x-intercept, we do the same thing, plugging in y as 0. So when we solve it all out, we plug in 0 for y, we get that negative 5x is equal to negative 7.5. Do not forget about that negative. When I divide a negative by a negative, we of course get a positive. that leaves me with a point of 1.5 comma 0. So now I have my 2 points that make my line. So now to graph the line using the intercepts, do exactly what we've been doing. Find your x-intercept and find your y-intercept, but then create the graph in this coordinate grid based on what size you need, and then plot the points and connect the line to make your line. And if you can do all of this without my help at all, you're doing pretty good. So pause the video and give it a shot. When I solve them all the way through, I find that I have a y-intercept of 4 and an x-intercept of 10. So that tells me that I can use positive for both of my axes, since my x and y-intercept are both positive. So I can go ahead and put my origin point somewhere down around here. I'm actually going to put it all the way down at the bottom. So take a moment, draw your graph, put the points on it, and connect them. So again, my line is not going to be perfect because my smart tablet, but I think I'm getting much better. My y-intercept point here is at 0, 4, so I just go vertically to get there. My x-intercept point is at 10, 0, so I'm all the way at the corner of my graph here. I did not extend my axes all the way, but you get the idea. So then I connect the 2 points, make my line, and from there I could derive the equation of the line, but again, we don't need to do that right here. All we needed was those points and to make the line. Alright, so these now should go quicker, so take a moment, pause the video, try to solve these, and I will actually show you a very nice shortcut method here as soon as we come back. So pause and try. So again, you have to forgive me, my line is not perfectly straight, but my y-intercept, because my x is 0, I can just ignore the x and say negative y equals negative 8, which then means y equals 8, which means my y-intercept is 0, 8. Same with my x-intercept. I can essentially ignore the minus y, since that'd be minus 0, which changes nothing. Say that x equals negative 8, which means that x equals negative 8, and this point is negative 8, 0. I plot down both those points, try to connect it with a straight line, but again, it's very hard for me to draw a straight line on here. So here you go, my best attempt. If you haven't done 4 yet, do it now. You can go ahead and use this method where for the y-intercept, we ignore the x, and for the x-intercept, we ignore the y. Alright, so now when looking at the coordinate grid on the right here, I've got my y-intercept as 0, negative 9, my x-intercept at 3, 0. Sorry that I'm making a few random lines around the paper. Let me get rid of those. And then we connect the 2 points with a straight line to finish off my graph. So there we go. So when I have this equation here, x is equal to 4, we're going to start talking about when we graph horizontal and graph vertical lines. Because if x is equal to 4, well, then does y have anything to do with the x? No. So x equal to 4, well, there's an x equal to 4, there's an x equal to 4, there's an x equal to 4, there's another x equal to 4, and we can do this all day long no matter what the y is. So anytime that you see an x equals equation, that is going to be a vertical line. So you can remember x equals something will be vertical. So then likewise, when we have a y equals situation, if y equals 1, then does the x affect that? Not at all. So if we have y equals 1, well, there's a y equals 1, there's a y equals 1, there's a y equals 1, there's another y equals 1 way out here. I mean, there's a ton of them. There's infinitely many. So that's why this will be a horizontal line. And again, sorry that my line got a little off there, but at the y equals 1. So y equals something is horizontal. And the way that the book says that you can remember this is through the statements hoy and vux. Yeah, that's a little dangerous to say. But vertical lines use the x equals, and horizontal lines only y equals. So whether you use vux or h-u-y or how you want to remember this, but horizontal uses the y and vertical uses the x. Maybe we should change that O to a U. Let's do hoy vux. So the last big thing that we need to talk about here is how we can take something written in like here we have point slope form and transform it back into standard form. And the big thing here is that we want to use integers. So notice that right now we do not have all integers, because remember that an integer is an entire number. That's how I get my class to remember it. So I can look at this equation, y minus 2 equals negative 1/3 times x plus 6, and I can rewrite all of this into standard form. So let me get started and then I'll pop right back in. So the first thing that we obviously need to do is rewrite this and start simplifying. So the first step towards simplifying, if we're following order of operations, which we must, is to try these parentheses, which we can't do. There's no exponent. So now we move on to multiplication, which this multiplication is going to distribute. So we now get negative 1/3 x, which is nice because now it's starting to look like my y equals mx plus b form. This is actually going to turn into a negative, and 6 divided by 3 gives me a negative 2. Now here's something interesting that I see now. I have a minus 2 on this side and a minus 2 on that side. If I just either think to myself or actually show the work that I could add 2 on both sides, well, that will cancel out both of those and leave me with just y equal to the negative 1/3 x. So now, since what we're looking for is integers, we ask ourselves, what do I do to this to turn it into an integer? Well, 1/3 you can just multiply by the reciprocal of 3 over 1, and I don't need to worry about the negative right now, and 3 over 1 is really just 3. So we end up with 3y being equal to x, but because we want it in standard form, we want the x and the y together on the same side. So now I'm just going, actually I have a negative x, do not forget about that negative because we had it up there. So now I just want to add x to both sides because that will get my y and my x together on the left side. And that actually leaves me with x plus 3y is equal to 0, which is in our standard form. Go ahead and try 7 and 8 to write those in standard form as well. So another approach that we can take with these problems is to get the integers first, since again with standard form we want to use integers. So to get integers here, because I have 1/4 x, I would need to multiply by 4, but because I'm doing that, it's going to happen to the entire right side. It also has to happen to the left side, which then leaves me with 4y equal to x minus 8, because after that 4 distributed, and then because I want the y and the x on the same side, I would subtract the x from both sides, and we would get 4y minus x, or minus x plus 4y, and order is kind of up to you, is equal to the negative 8, and there we would have it in our standard form. Go ahead and try 8 if you have not done that yet. So here we can multiply by 3 on both sides. We get 3y is equal to negative 2x minus 3, and then when I want to get them to the same side, I can add 2x to both sides to get my variables together, or at least on the same side more so. And it is actually preferred to write the x first, just to be in nice order. So we can say 2x plus 3y will be equal to a negative 3, and there is our standard form using only integers. So then we have situations like in the real world where a standard form equation is useful to us. So here we have that in a video game I earn 5 points for every joule, and I earn 2 points for every star, and we need 250 points. So go ahead, pause for a moment, and try to write an equation where we could use standard form to model getting joules and stars to get up to 250 points. So here we see, because it's 5 points for every joule, we'd have 5 times J. Because it's 2 points for every star, we'd have 2 times S, and that will equal our 250 points. If I substitute in 0 for either of these, as if I had 0 stars, then 5 times the joules would have to equal 250, which would give me a joule amount of 50. If I had no joules and only stars, then I would have to have 125 stars, and then I could make a graph to represent all values between there using those two different intercepts. But because we're running out of time, I will just stop here. Please make sure that you've worked through the Pearson modules and you work through the homework, at least half of it until you're confident. And I will see you guys in class. Thank you and have a wonderful day.